Hey y'all, alright, so I'm going to be teaching you how to do problem number 2 of 18.1. Alright, so this is going to be about work and basically change in pressure and change in volume at constant temperature. And so, how do you calculate work? Alright, so remember, work is basically the amount of energy that was done by a system or by its surroundings, right? And so, if you recall, there's this really nifty graph called the PV graph, where you have pressure and you have volume. So problem number 2 is asking how much work in joules is done when oxygen is compressed from a volume of 22.8 and external pressure of 1.2 to 12.0 liters at constant temperature. I'm assuming it's also meaning at constant pressure because it's external pressure, and so pressure isn't really changing. So what we have is basically 1.2 atm, and we have a change in volume right here. So what we can do is we can use the equation right here, right? So this is our change in volume, and it went this way, right? And this is what, 22.8. This is 12.0 liters, right? And that's very vital when we go to our conversion factor, right? So you take the 22.8 and you say, alright, it's going to 12, so what's that change in volume? Because our equation is work is equal to negative P delta V. And that's basically the area under this curve right here. So it's like this boxed region right here, shaded box region. And so to calculate that, you say, alright, my pressure is 1.2, change in volume is going to be final minus initial, so you have 12 minus 22.8, right? And you have a negative sign in the front, so this is equal to work. And you calculate it out, and you get a total of 12.96 atm dot liter times liter, right? And is it positive or negative? It's positive, right? So first of all, this means that work is being done by the surrounding, because basically what's happening is work is compressing the gas, and so in order for work to compress the gas, you have to put work on the system. The system isn't doing work. If anything, then yeah. Okay, and so what's going to happen next is you have to convert this into joules because that's what they want. And lucky for you, there's a nifty little conversion where 1 atm dot liter is equal to 101.325 joules. And so you just multiply that out and you get joules. And how much joules you get is 1,313.2 joules. Alright, and so that is your answer.